Good afternoon. Welcome back after a long time. So today we are going to discuss about the data validation or data governance in ETL projects. Generally, data governance is nothing but when we are moving the data from one source to another source, we need to check either the schemas of the source and target or match, and the column counts and the column names. Any missing columns are there here and there or not. Those kind of data governance checks generally we will perform in any kind of ETL projects. That choose of tool may be different. Some maybe go with ADF. In ADF we have the data flows and all. Some maybe choose the Databricks with the Pyspark or Scala. So we are going to do with the Databricks with the help of the Pyspark. So data governance with the help of the Pyspark. This is the real kind of scenario. Generally, real world scenario we will say it. Okay. So that is going to develop in a dynamic way. Dynamic way is nothing but we will define a metadata table or control table. In that control table, we'll define the values like source file name, source column name, column types, source column names, and the destination column names and destination schema type. So like that, we are going to mention in a metadata file. So that what will happen means we will return one function for column comparison and we will return another function for the schema comparison. Okay. So for those functions, we will pass the parameter as a this kind of metadata file or control table. Okay, we will going to perform those things, so don't worry about it. Wait a moment. Yeah, this is the scenario. Consider you are going to develop a pipeline which is going to transfer the data from the source that may be any kind of source, okay, to the stage layer as of now. Here we will consider a source as a we have the we have the three different sources. Okay, one is orders and one other one is people and another one is the returns. So once data landed in the stage layer, we are going to develop the data validation pipe, data validation kind of things or data governance things. Nothing but comparing the columns between the source and the target data. Target data here is nothing but the stage, okay, stage data and the schema comparison. So once this comparison validation has been passed, we will move it to the destination layer. Okay. So for in this video, we are not moving to the destination layer. We are checking whether it validation is done properly or not only. Okay, not an issue. So to perform this process dynamically, like I mentioned previously before, we are going to create a reference data frame. Reference data frame is nothing but a metadata file has been defined, and we will read it in a Pyspark that is named as a reference data frame, okay, which have the source column name and source data frames and all. And also we will define a control data frame. Control data frame is nothing but like I defined, right? We will going to design a two functions. One is for column comparison, another one is for the schema comparison. We know function is nothing but we have to pass the parameters. Imagine we need to validate 10 to 20 data frames. Okay, it is not going to be possible like one data frame equal to sorry, column comparison for one data frame, column comparison for one to two. It is possible, but it is a heavy process. I mean, we need to hard code a lot of things. So what is thing behind the metadata frame or dynamic means one function has to work for the multiple data frames. That is what we are going to perform, right? So this is the flow. So we have the data at source, okay, and with the help of the ADF, we move the data to the stage. Here I am not going to show the ADF pipeline. Why? Because I don't have the account. Just I'm creating a scenario on Pyspark. Okay, let's imagine. So in the stage layer, we need to perform the data validation and data governance, and then move it to the raw layer. And this is the glimpse of the configuration files or metadata files. This is the reference data frame, okay, which have the source folder name, nothing but orders, Okay, like I previously mentioned, we had three data sources, right? Orders, returns, and people. And a SRC file name, source file name. Okay, source column names, source column types. Okay, SRC file name. What happened? Just yeah. SRC file name and SRC column. These two are very important for us. Okay, SRC file name, SRC columns, and SRC column types. These three are very helpful for us. And this is the control data frame. This is helpful to pass the parameters for the function. Okay, here we will define a file path, file name, and a reference data frame. Okay, as part of the parameters concern. Right, don't worry about it. We will see each and everything in a detail so that you will understand. Okay, in this video we are going to do the column comparison. In the next part we will do the schema comparison. Okay, so we'll go to the database. I hope you people know how to create a cluster and all. If you don't know, go to the compute and create a compute. Okay, give the name of your cluster whatever you want. Once the cluster has been created, we have to load the data into our DBFS. Like I said, I don't have the Azure. That's why I'm considering DBFS as my source, distributed file system. Okay. So in the distributed file systems, as part of my source concern, I created it three folders. One for orders, which will stores the orders data. Another one is the people, which stores the people data. Another one is the project, which stores the, sorry, not project, returns. Sorry, returns, which will stores the returns data. And for the configuration file or for metadata files, I created one more folder called as a configs, which will store the control table and reference data files. Okay, so go back to the workspace, create a folder called as YouTube as your name, your concern. Okay, so and create one notebook called as a setup file. So if you don't know how to create a folder in a DBFS, then use this command. Okay, make a directory called configs or make a directory called orders and all. Okay, once the folder has been created, just upload a file. Okay, we need to upload a file like this. Go to DBFS. Even though if you select the configs, see, even though if you select the configs, whatever the file you are uploading, it's going to deposit it in the file store. Okay, now what we had to do, we had to bring the file present in the file store to the respective folder. Okay, so for that one, I am just copying the file from the file store to the our destination, right? So that the files will going to be copied or moved. Once the data has been moved into the respective config, just run it like this. Okay, right. Now this is called as a setup notebook. Why? Because why I'm saying setup notebook means every time I am not going to create or what we I say, every time I am not going to create a reference data frame, control data frame in each and every notebook. I am going to define those things in a one notebook called as a setup notebook, and I am going to use those variables, okay, in each and every file. Not like defining again the orders data or control data or reference data frame in each and every node. Okay, I am defining it in setup and using everywhere, right? So first important thing is we need to import the configurations from Pyspark.sql. Okay, import the Spark session, import Spark session. Next, from Pyspark. Spark contains we don't need as of now. Okay, Pyspark.sql.functions import stuff from Pyspark.sql types import star. Okay. Now, now what we have to do, we need to take the data from the configs or from anywhere. Sorry, just wait a minute. Comment in this. Now we need to create a reference data frame and control data frame. Okay, we need to create these two things. For reference data frame, the data has been stored in a configuration folder. I mean, the file path has been stored in a configuration folder, right? We need to read it from there. Okay, so let's do one thing: db utils.fs.ls. Make sure we have the data in the respective folder. It's running. Will run. Got it. So as you can see, we have the config, right? Copy this one. So configs. Right. As you can see, we have the reference data frame.csv and control data frame.csv. So let's create it. Moreover, we need to create a Spark session. Spark session. I forgot about that one. Sorry. Let's say Spark underscore session equal to Spark session dot builder dot app name. App name. Let's say YouTube. Anything. Dot next what we have to do master it refers to the cluster configuration. I'm selecting local star dot you can it doesn't require as of now have and remaining configuration. I just get up here. I will create that one and run it. App name missing required position. What was this again? Not capital B, right? Small b. Done. Now let's create a reference data frame. Okay. Spark session dot read dot format csv dot option header. I want header option info schema as to dot load. Okay, take this part. So the majorly the reference data is nothing but it is like a reference structure. Okay, which describes the schema and the column names between the source and destination, right? Control table is for passing the parameters. Okay, don't confuse. Yeah, reference data frame is done. If you want, we can show here or we can show it in a next notebook. Let's create a control data frame. Okay, same thing. Okay, I'm just copying and paste. Just change the path for the control table. Okay, Done. Now let's create another notebook. Uh, Go to YouTube and duplicate the screen. How to? Now we are back. Go to workspace. Go to the respective folder and create a new notebook. Let's say NB validation. Okay, NB validation. So the first thing we need to do, use the run command, run magic command, run the setup notebook. Okay, setup notebook, we need to copy this path. Okay, copy file path and paste it. Control N. Yeah. So we imported whatever the variables, whatever the data frames we defined in a notebook, and I mean setup notebook to this validation notebook. So we need to check it out, right? Reference data frame. Reference data frame. See, it is defined in the setup. I'm not here. Just show 10 values. It's fine. Okay. SRC file, SRC columns, and SRC column types. And you may ask one question, sir, where we are defining the data frames for the orders and data frames for the returns or data frames for the people. We are going to define those things in the function itself so that we can make it as a dynamic, right? Next, control data frame. Say control, yeah, control df dot show. Okay, so we have the file path, right? For this file path, we are going to take this file path in a function and we are going to create a data frame in the function itself. Okay, so column comparison. Okay, let's define a function df column comparison and pass the parameter values control data frame. Okay, control data frame. Control data frame is nothing but whatever we define, and Spark session we need to pass it. Why? Because we need to define that data frame inside the function, right? For that one, Spark session required. Okay, or else we can simply go with built-in spark.id instead of Spark session. Okay, and just showing the one way. There are a couple of ways out there. I found it's a best way to do the things. And the reference data frame. Okay, that's fine. So the first thing what we have to do means we need to iterate control data frame and get the file name and file path for creating the data frames for the respective source orders and returns or the people, whatever. Okay, so for x in control df dot collect. Why I'm collecting? Because I make it data frame converting into the list. Okay, and iterating. That's the main thing behind the collect. So file name equal to, so x of x of x of file name. Okay, okay, I will just print it for now and I will show you. Okay, file name and file path x of file path. print file path. Okay, I will show it in both side. Okay, not in the function. Let's change it here. Control data frame and check the indentation. Okay, fine. Order state is a file name and the file path. Now, once of the file path and the file name, we got it. Next, we need to define the data frames. Define the data frames from the file paths. Okay, so let's name it as DFS data frames shortcut name and spark.read.write, but we define a parameter spark session dot read dot format CSV. It's better convert everything into one format. Okay, whatever the data we got it. Of course, it's depend on sometimes the requirement and all. Okay, I am assuming like this. Even though there are different files, here and there something will be changed, but the framework looks like this same only. Option header group dot option infer schema dot load. So what we need to load? We need to load the file path, right? File path. This just for a second. Okay. So the file path has been going to be loaded, and let's add some sample print statement here. Print like a file path. Let's say data frame. Data frame is creating for respective file path, okay, or file name. Okay, dot format file path file name. Okay, now again copy this one. It is not required, I am showing. But data frame is created, right? DF created, data frame created. Okay, now we got the data frames, and from the data frames we need to take the columns. Okay, we need to take the columns. So df underscore columns. So here what I am doing again, suppose the source columns, it is in a capital, suppose, let's say assume, and the columns in the stage is in the lowercase. Okay, the comparison won't be done at that time. So why? Because Python is a case sensitive, right? So what I am going to do, converting the data frames columns into lowercase, as well as converting the column names of the source or the reference data frame into the lowercase as well. And I am doing the distinct one. Collecting the distinct is nothing but a set. Okay. First of all, set dfs dot columns. Okay. Now we need to make the each and every element in the set to the lowercase, right? So I want to iterate through each and every element and make the columns into lower cases. I mean, make the string into a lower cases. For that one, I'm going to make utilize of the map. Okay. Map str dot lower. Right. So I will going to print this one as well later on. Okay. Now we got the columns of the data frames. Okay, data frames presented at the source stage. Sorry, not at source stage. Now we need to get the reference data frame. I mean, we need to get the columns from the reference DF. Okay, so that we can compare what are the missing columns are there. To get that one, we need to take the reference data frame, filter the data frame according to the file name. Why I'm saying we need to filter the file name according to the, we need to filter the reference data frame according to file name means, here I am showing only 10. I am going to show 30 for now. Okay. So if you see the file name, orders data, fine. And we have the returns data, people's data also. So if you don't filter according to the file name, this data frame going to compare each and everything irrespective of data frame. If you don't filter, the orders data going to compare with the returns data and the people data also. So we can encounter the error. Okay. So what I am going to do, I am going to filter this one. Okay. Filter this one. I'm going to filter. So let's see here. Say reference filter. Reference filter is equal to refdf is a parameter. Filter column of src file name equals to the file name, whatever we define. Okay. From the whatever we get it from the control data frame. Once the reference data frame is filtered, we need to get the columns. Reference columns, let's say reference columns. Reference columns equal to reference filter dot. I want only column which contains the all column names. Okay. So that I have the source columns. Source columns is the columns which contains the all the column names of the respective files. So I am going to select that one only. Why? Because that's the most important thing for us. Source columns. Okay. Once after selecting the source columns, now I need to make this. I mean, I need to split it into each and every single line. Okay. I need to split into each and every single separate line. For that one, we are going to make use of the flat map. I'm going to convert this to rdd dot flat map lambda. Why? Because iterated, we will get it. Okay. Dot current. Okay. So what we will get it means we will get a complete string from this one. And again, I am taking the distinct means set. Okay. Once after set, we need to convert into lower case as well. Like I said before, it is a case sensitive. Once the source and the destination columns maybe some sort of one is uppercase, another one is a lower case, we will get an error at the time of testing on that. So str dot lawyer. Now that's fine. Now we got the reference columns as well. So we need to define a missing columns. Missing columns is nothing but taking of the reference columns minus df columns. Okay. If missing columns, write a condition. If missing columns, let's say print. What we need to print? Anything like columns mismatch for the so on so file like that we can print. Let me recollect what we need to print. Sticking out there. Okay. Let's say column names does not match for the respective file name. Okay. Dot format file name. Okay. If you keep return true here, what will happen means or return false. Okay. Does not format and we need to print the what are the columns missing, right? And missing columns are fine line comma missing columns. So if you define a return false means, so it will check if the orders data has the missing columns, it won't go for the remaining returns or remaining people. It won't check either they're missing or not. So that's why I'm not keeping return false here. Okay. Else print columns match for the files dot format file. Okay. We can put it in a try catch as well if we want. As of now, we are running out of time, I guess. Don't worry, we'll put it in the try catch. Everything has been inundated perfectly. Let's check it out from top. Try for, okay, except where it is going. Sorry. Set exception if print any kind of error, I think. Print format this and error, and we need to format this string alias e. Okay, and return. Okay, run this one. Yeah, okay. Now check column comparison. Control df equal to control data frame what we define. Okay, sp session equal to spark underscore session. We define it as setup itself. Reference df equal to reference data frame. No, I run it. Data frame, as you can see, data frame is created and it is printing the column names. Okay, this is what you will get it. Okay, from the map set. See, columns match for the files order data. Okay, for order data, this condition is false, and columns match for the files return data also. Okay, so this is the what we are going to run as a dynamic. Okay, so what we had did entirely, we define a function and making instead of pausing, suppose if we don't have the control data frame, what we will do? Okay, like a column comparison and just experimental this one. Okay, like orders underscore data and some other parameters like we will pass like this under reference data frame. Okay, again column comparison for people data, some other parameter and a reference data frame. Okay, like this we will do. Okay, if it is Okay, generally there are large number of sources are available in the real time, right? So it is not a best practice as of concern. It's depend if they're okay, we will go with it. It doesn't matter. We will get a small kind of data. That's fine. So if there are number of sources are there more than 20 or 25, then it is very simple. Maintain a control data frame. Okay, if you want to do anything change, no need to go and change everywhere as you define. Just go to the control data frame or just go to the reference data frame, and we will update whatever we want. So what we did a single update, and everything is going to be changed. Not like going to each and every time where you define, we need to search it where I define and where I need to change. So the control data frames or the reference data frames will solve the problem. Define or update one place, I will take off the chances in remaining things as well. So that's it for this video. In this video, we check for the column comparison, and the next video we will check for the schema comparison. Okay. So validation has been passed. Sir, you can say, sir, validation has been passed, and then what we have to do means you can just write if we have the mount point. Okay, if we have the mount point, we can move this data frame. Okay, resultant data frames to the another destination. Okay, then you can pass it like dfs dot write dot mode overwrite. Okay, mode dot overwrite dot format dot, either you want csv or anywhere. Okay, load and then destination. Like this, we will write the data frames to the required destination. Right? That's it for this video. In the next video, we will check for the schema comparison. We will follow the same pattern itself. Thank you.